So, good morning, everyone, and welcome to this special lecture. In this lecture, we are going to start and end with a very important concept on which we are supposed to get a lot of questions. At least one question in every section will be coming from this particular section, and this particular section is known as logic gates. It's a very simple exercise, and we should be doing it with a lot of examples, and one of those examples might be there in your exam, in your attempt. Now let us move ahead with logic gates. This branch is known as digital electronics. It comes in this branch of physics, which we may call as digital electronics. Now, whenever we talk about digital or the binary system, let us have a look at digital or the binary system. Now, in the previous classes, we had seen what we call as AC voltage. Do we remember this? AC voltage is continuously changes its direction. It may also change its magnitude. Yes or no?
Yes, sir.
We will see this in a different light now. Let us take it in terms of voltage. We can also take it in terms of current. If you have a voltage or a current which is continuously varying, it is continuous. It is continuously varying with time, then that type of voltage signal or current signal or AC signal or in general signal is known as your analog signals. This is the example of an analog signal. This is what we use, analog. If we talk about a digital signal only has two values. Either it's a constant high value or it has a zero value. This type of signal, you can also call it binary system, is known as a digital signal which only has two values. It's like a switch. Either it is on or it is off. In binary, which we are going to see, we will call it 0 or 1. 0 means off, 1 means on. 1 means maximum value, 0 means zero value. This type of signal is known as a digital signal. Do we understand this?
Yes, sir.
I'll give you a minute to note this down. Having seen what is a digital system, we can see what is a binary system. A binary number system has only two digits, 0, which is low value, and 1, which is the high value. Do we know this all?
Yes, sir.
1 means on or high, 0 means off or low. We understand this?
Yes.
These are the different ways in which you can call 1. 1 is on, up, close, excited, true, pulse, high, yes. 0 is off, down, open, unexcited, false, no pulse, low, and no. I'll give you a minute to note this down. Since we are now exposed to this binary system to add or such to do operations on this binary system. If you remember your number system 0 to 9, 0 to 10 or whatever, you have addition, multiplication, and all those operations that can be done. In binary system, the operations are done with something which is known as the Boolean algebra. What is this Boolean algebra? I hope you have heard about this. In Boolean algebra, as in binary system, only two values are allowed, 0 and 1. Now, with 0 and 1, what you can do? three operations we have to understand. The first operation is known as the OR operation. The second operation is known as the AND operation, and the third one is known as the NOT operation. I hope you understand this, yes or no?
Yes, sir.
The OR operation is denoted by a plus sign, or either this or that. Now, plus means if you have two inputs, A and B, the output will be A plus B. This Y, you can see, this Y is nothing but the output. Do we understand this?
Yes, sir.
So the Y output in case of OR operation is A plus B, and this is how you can draw an electrical analog of the same. You can see, do you see a battery here?
Yes, sir.
Do you see a lamp here? Now to understand this operation, what you have to do is you have to understand when will the lamp glow. The lamp can glow if current flows through this. The lamp can also glow if the current flows through this. Yes or no?
Yes, sir.
The lamp will glow if A alone is operational or A alone is on. Lamp will go when B alone is operational. Lamp will also glow when A and B both are operational. Lamp will not glow when both A and B are off. This operation is known as the OR operation. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
Okay. Then we come to the AND operation. In AND operation, the AND operation is signified by dot. Dot means multiplication. Lamp, when will lamp glow? In this case,
Only both are on, sir.
when both are on, then only the lamp will glow. The NOT operation is the reverse of this. The lamp will glow when A is not connected or A is off. Do we understand this?
Yes, sir.
And it is denoted by this sign. Everyone understands this?
Yes, sir.
When the switch is put on to position A, in position A, the current will just flow like this and lamp will not glow. When the switch is off, then the current will flow like this. Do we understand this?
Yes, sir.
Give you 2 minutes to note this down. Then we can look at some basic operation of the OR gate. For example, 0 plus A will be equal to A plus 1 will be equal to 1, and A plus A will be equal to A. You can take an example, 1 plus 0 will be equal to how much? If you take A as 1, 1 plus 0 will be equal to 1. 0 plus 1 will be equal to how much?
1.
0 plus 0 will be equal to how much? 1 plus 1 will be equal to how much? It will not be equal to 2, it will be equal to 1. Do we understand this?
Yes, sir.
AND gate A dot 0 is 0, A dot 1 is A. A dot A is equal to A. You can also take example, A dot 0 will be equal to how much?
0.
0 dot A will be equal to how much?
0, sir.
0 dot 0 will be equal to how much?
1, 0.
1 dot 1 will be equal to how much?
1, sir.
And on the NOT gate, A plus A naught or A bar will be equal to 1. A dot A bar will be equal to 0. A double dot A bar bar will become A. So A dot A will become equal to A. Do we understand this?
Yes, sir.
For example, 1 plus 1 dot 1 bar will be equal to how much?
1.
1 dot 1 bar will be equal to how much?
0, sir.
1 double bar will be equal to how much?
1,
1. 1 double bar dot with 1 will be equal to how much?
1.
You have 2 minutes to note this down. Then we can move on to some Boolean postulates and Boolean law. No one is going to ask you what are Boolean postulates. 0 plus a is a dot a is a, 1 plus a is a, 0 dot a is equal to 0, a plus a dot is equal to 1. Commutative law, a plus b will be b plus a. Distributive law, associative law, identity law, negation law. We all understand this? Or do
Yes,
I need to explain them?
we understood, sir.
Everyone understands this?
Yes, sir.
Then we have something known as the De Morgan's theorem. Do we know this De Morgan's theorem?
Yes, sir.
What is De Morgan's theorem? You might have read it in sets. A plus b, the whole bar will be equal to a bar dot b bar. A dot b ka whole bar will be equal to a bar plus b bar. Do you understand this?
Yes, sir.
You have 2 minutes to note this down. Then you can also note down some other useful identities. These identities may be required when a very difficult question comes. I will just show how these identities come, just one of these. See, a plus a into b is a. How I can prove this? You can also prove all these identities. I'm just showing it, showing one of you. So it's showing one of those identities. I can take a common. It will be equal to 1 plus b. Now 1 plus b is how much?
1.
And a into 1 will be how much?
1.
So a
Sorry,
into 1
sir.
will be equal to a beta. So that is how I will get these identities. Just note them down. That takes us to the main heading of this chapter, and the main heading of this chapter is a logic gate. What do you understand by a logic gate? What do you understand by a logic gate? So a logic gate is a digital circuit which can be analyzed with the help of Boolean algebra. It's a gate, it's a digital circuit, very precisely, that can be analyzed using Boolean algebra. It may have 2 or more inputs. It can also have 1 input, 1 or 2 or more. You can add 1 also here. But it only has 1 output. That is, my dear friends, a logic gate. Basically, how many types of logic gates are there? There are 3 basic types of logic gates: OR,
And not.
and NOT. What are the important points that you must remember about a logic gate? It is a digital circuit based on certain logic between the input and the output. Output depends on input, and between input and output, there is some logic. These logic gates are built using semiconductors, p-n junction diode. They can also be built using transistors. Each logic gate has got its symbol. We will see its symbol as well. The operation of logic gate is indicated in a table. This table is known as the truth table. What is a truth table? Truth table is a table that contains all possible inputs and gives the value for all possible inputs. It gives us the value of all possible outputs. To write the truth table, we use the digits 0 and 1. Do we understand this?
Yes, sir.
A logic gate will also be represented by Boolean algebra. So any logic gate can be represented by Boolean algebra. We all understand this?
Yes, sir.
You have 2 minutes to note this down. So now we move on to the different type of logic gates. The first type of logic gate is an
Or.
OR gate. It has two input, one output. Why? Y is A plus B. That is the Boolean expression. The output of an OR gate will have value 1 if any one of the input is 1. Yes or no?
Yes, sir.
This is the symbol and this is the truth table. I hope everyone understands this.
Yes, sir.
I'll give you 2 minutes to note this down quietly. Then the next one is the AND gate. Two inputs, one output, A dot B. It attains the state if only if both inputs are
One.
1. This is the symbol and this is the truth table. I'll give you a minute to note it down. Then we move on to the next type of gate. And what is the next type of gate?
Not.
The next type of gate is known as a NOT gate. And what happens in a NOT gate? What happens in a NOT gate? The output will be 1 if the input is 0. Do we understand this?
Yes, sir.
Everyone knows this?
Yes, sir.
The truth table and the logical symbol and the other information is given here. I hope everyone understands this.
Yes, sir.
I'll give you a minute to note it down. We then move ahead and we look at some of the combination of these gates. What is the first combination that we will see?
NOR gate.
Let us look at the first combination and let us look at the NAND gate. Have you heard about a NAND gate?
Yes, sir.
The NAND gate is a combination of a AND gate.
It and
The
not.
output from the AND gate is now put in a NOT gate and we get the final output. The small circle, small after this AND gate tells us that this is a NAND gate. Do we understand this?
Yes, sir.
The Boolean expression of the NAND gate. How will I write the Boolean expression for the NAND gate? The Boolean expression is the result which I will get finally. So that result y, this y that we get here, this y will be equal to A dot B ka inverse. Yes or no?
Yes, sir.
I'll give you 2 minutes to note this down. Everyone understands the truth table?
Yes, sir.
That was the NAND gate. What is the next gate that we should see? Is everyone there?
NOR gate, sir.
NOR gate, and as expected, you put a NOT gate. You put a NOT gate after a OR gate. This is the output from the OR gate. Y is the output from the NOT gate. This combination with this small circle becomes a NOT gate. We understand this?
Yes, sir.
The Boolean expression for this NOT gate would look like this: A plus B ka bar. Yes or no?
Yes, sir.
Everyone understands this?
Yes, sir.
Everyone understands the truth table? You have 2 minutes to note it down. Then the next type of gate is known as the XOR
NOR
gate.
gate.
Have you heard about the XOR gate?
Yes, sir.
This is known as the exclusive OR gate. Exclusive OR gate is known as the XOR gate. What do you understand by XOR gate? This is a logic gate which will give you the value of 1 if any one of A and B is 1. Do we understand this?
Yes, sir.
But if both of them are 1, it should not give you 1. Do we understand this?
Yes, sir.
So a logic gate which gives high output 1, if either A or B but not both are
Both
1, is known as
are okay.
the XOR gate, or very simply exclusive OR gate. Do we understand this? Everyone understands this?
Yes, sir.
This is how a exclusive OR gate looks like. This is how an exclusive OR gate looks like. Can anyone tell me what is there? Can anyone tell me what is happening there? Let me put different pick. Can you tell me what is happening there? How is this functional? Yes. Let me. I've put a bigger picture. Can you tell me what is happening? Yes. Can anyone tell me what is happening? It might look a bit haphazard, but it
Sir,
is completely making sense. Yes. What do we have here? How many gates are there to make a XOR gate? What is this?
not gate, sir.
What is this?
Not gate.
What is this?
And
What is this?
and
So two and two NOT gate make an exclusive XOR gate. On this side you have A, so here you will have A bar, or here you have B, so you will have B bar. Do we understand this?
yes, sir.
So the output from here will be A dot A bar dot B. The output from the other side is A dot B bar. You AND it. This is the Boolean expression A plus with a gola B, and the output is A dot B plus A bar B plus B bar A. Do we understand this? And as you can see, when 1 plus 1 is there, we don't get 1, we get 0. That is how it is different from a OR gate. Do we understand this?
Yes, sir.
And this, my dear friends, is the symbol of a XOR gate. Everyone understands this? Or
Yes.
this has gone above our head saying bye-bye. Combination of two NOT and two AND. Everyone understands this?
Yes, sir.
You have 2 minutes to note it down. Try to draw the diagram on your own. Once you understand that the Boolean expression is A bar B plus B bar A, I think it's written wrong. A bar B plus A B bar. So just correct it. Let me just correct it. Let me just correct it. The Boolean expression is A bar B plus B bar A. Do we understand this?
Yes, sir.
That is the Boolean expression for a exclusive XOR gate. Try to draw the diagram on your own. Try to draw the truth table on your own. This is very important because this might just appear in your exam. Then we have the next gate, which is known as the exclusive NOR and XNOR gate. This is a combination of XOR plus NOR. So you have this XOR gate and you add a NOT gate. This is the symbol of a XNOR gate. The Boolean algebra is A dot Gola B or A bar B bar plus AB, or you can write it as A plus B Gola A plus B, which is the XOR gate, and we put a NOT gate. This is the truth table. Try to write the truth table and understand it on your own.
Yes, sir.
And we come to the stage, because these questions are coming these days. Universal gates. What are these universal gates? Any NAND gate or NOR gate. If you take a combination of NAND gates, only NAND gates, or you make a combination of NOR gates, you will be able to make any possible gate that is possible. Remember, if you can make 3 gates, or and not, you can make all the possible logic gates in the universe. Now to make this or and not, or and not, you can only use either NAND gate or NOT gate. Therefore, NAND gate and NOR gate are known as universal gates.
Gates.
Using just NAND gate only or using NOR gate only, we can make all the gates in the entire universe. For example, how can you create a NOT gate from a NAND gate? And remember this so that you don't have to look at it every time. When all the inputs of a NAND gate are connected together, you see, and NOT gate only has one input. So what do? You connect all the inputs to one point, and the end result will be a NOT gate. When all the inputs of a NAND gate are connected together, the output is a NOT gate. This is the truth table of the diagram that I have drawn. Do we understand this?
Yes, sir.
So by connecting all the inputs of NAND gate to just one input, you will get a NOT gate. Do we understand this? Do we understand this?
Yes, sir.
Remember here, A is A, but B is also A because B and A are not different. Do we understand this? So we get a NOT gate. Remember these configurations. This is how you can create a AND gate from a NAND gate. So this is a NAND gate, and you add a NOT gate. Combination of NAND and NOT gives you AND. So you can write it like this: NAND plus NOT will give you the combination as an AND gate. This is the way to remember it. Do you understand this?
Yes, sir.
You'll have to remember this. If you don't remember this in the exam when they come, you will have to understand the truth table and then understand the output. If you can remember them, you will save a lot of time. I'll give you a minute to note it down. The next thing is, how do you create a OR gate from a NAND gate? So you can see this is effectively a NOT gate, yes or no?
Yes, sir. It is a
A
not.
NAND gate converted into a NOT gate, and this is a NAND gate, yes or no?
Yes, sir.
So basically 2 NOT gate, which is nothing but a combination, which is created from a NAND gate, plus a NAND gate will land up at an OR gate. If you can remember these simple things, life is going to be very simple. And similarly, we can see how we can get all these gates from NOR gate. If you put all the inputs together, you will get a NOT gate from a NOR gate. Do you understand this?
Yes, sir.
If you put a NOR gate with a NOT gate, you will get a OR gate. Do you understand this?
Yes, sir.
You put two NOT gate plus one OR gate, you will get a AND gate. Does
And
this
it.
does this remind you of something that we have already done?
Yes, sir.
You put all inputs of a NAND gate together, you will get a NOT gate. Yes or no?
Yes, sir.
You put a NOT gate with a NAND gate, you will get a AND gate. Yes or no?
Yes, sir.
You put two NOT with a two NOT with a NAND gate. I have written it wrongly here. Two NOT with a NAND gate, you will get an OR gate. If you put two NOT with a NOR gate, you will get AND gate. Do we understand the similarities?
Yes, sir.
This is how, if you can remember them, you will have a jolly good time solving questions that are coming. I'll give you 2 minutes to note it down. If you can write them on your own, that is what I would like. That will tell me that you have understood the concept and you have also understood how to remember them. Everything now put together in one table. OR gate, symbol, boolean, truth, electrical analog, and this is how we represent it digitally. And symbol, boolean, truth table, electrical analog, and this is how you represent it digitally. Not tongue, 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 tongue. You have to just note it down. Everyone understands this?
Yes, sir.
Draw it patiently, aram se, quietly, with your own understanding, in your own handwriting. If you can draw this, that means you have understood it. Then we move on to the next three, the NOT, NOR, and the NAND gate. Truth table, Boolean algebra, expression, symbol, electrical analog, digital analog, everything is there. Remember, two diodes. I think we are done. Or and not, no, NAND. Okay. Not was there in the previous thing as well. Remember, two diodes like this, they represent a OR gate. Two diodes like this, it represents a AND gate, and this transistor represents the NOT gate. Do we understand this?
Yes, sir.
If you remember this, it will be easier for you to draw the digital analog of this. Give you 2 minutes to note it down. Then we just have the remaining two, XOR, the exclusive OR, and the XNOR, exclusive NOR gate. Give you 2 minutes to note it down. Everyone understands this?
Yes, sir.
Then we move to this question. This is from JEE Main of 2023. Which option is this? Which option is this? What type of gate is this? Is it a NAND gate, a NOR gate, a OR gate, or a AND gate? Which is the correct option? Yes, my dear friends.
Sir. Fourth option.
It's an AND gate. It's an AND gate. When any one of this is off, current will flow from this branch. So if this is 0, this is 0, this will be 1. If this is 0, this is 1. This would be 1. If this is 1 and this is 0, this would be 1. In only one case, it would be 0. And my dear friends, this is an AND. This is a NAND gate for that matter.
Yes, sir.
I will not comment anything. If you whatever, you have to be careful. If you just do things like this, it's not going to come out good. Anyways, may God help you. This one, this logic gate, this is 2019 JEE Main. This logic gate is equivalent to which gate? Can I have the answer for this? Can I expect an answer for this? That would be a better way to say. Can I expect an answer for this? What is the answer for this? Yes, my dear friends.
OR gate, sir.
It's a combination of what? Two NOT
gates and one AND gate.
NOT AND gate, two NOT gates and one NAND gate
Sorry.
will give you an OR gate. As I told you, most of the question that you are going to see will appear from somewhere in the notes. If you are good enough to remember it, remember, the only thing you have to remember is to remember things. The only thing you need to forget is the habit of forgetting things. If you can do that, nothing can stop you from getting into a decent college in NITs or IITs. This is from 30th Jan, shift 2. The question comes here. Which is the correct option? Some combination is given, and I hope you will be able to tell me which table, truth table, is correct. Give you 2 minutes to do this. Let me check. If I put 0 here and if I put 0 here, okay? Here it will be 0. Here it will be 0. Yes or no?
Yes, sir.
Okay. Here it will be 0. Here will be 0. Yes or no?
Yes, sir.
What will I get on the other side?
1.
It's a NAND gate, 1. So 1 will go here. 1 will go here. Yes or no?
Yes, sir.
1 and 0. NAND gate, what I will get?
1.
1 here, 1 here. Yes or no?
Yes, sir.
1 and 1 NAND gate. What will I get?
0, sir.
So for 0, 0, I should get 0. Yes or no?
Yes, sir.
So option has to be either 1 or 4.
1, 4.
Now you can just check any one. You can check the fourth one or you can check the second one. Anything that you will check,
1, 1.
you just match it and you get your options, and the answer that is given to me is option number 1. I hope you are getting it. Yes or no?
Yes, sir.
This is how questions are framed in a JEE, my dear friends. And if you are good enough, you don't even have to be good enough. You just have to be remembering enough. This is a question. As you can see, similar question from the JEE of 2019. I'll give you 2 minutes to give me the answer for this one. So how are you supposed to do this? Let me use 0 and 0 here. If it is 0 here, it is 0 here. If it is 0 here, it is 0 here. 0 and 0 after an AND gate will give you what?
1.
Take deep breaths.
Okay.
Close your eyes.
0, sir.
Think about it. Open them. Look at there and then give me. 0 and 0 on an AND gate will give you what?
For
Uh,
or it is
sorry,
1.
0 and 0 on an OR gate will give you what?
0.
0. Then 0 and 0 on an AND gate will give you what?
Be 1, sir.
It's a NAND gate, sorry, not an AND. 1. So 0, 0 should give you 1. The correct option has to be from A or B. Now you can just check this option. I always check this one and you will get the answer. Which option is coming?
1,
Option
1.
A or B or
1,
C?
1. 1, 1.
Sorry. This one can also be correct because 0, 0 will be equal to 1. So you'll have to check that option where you probably would have to check two more options to get the right answer because all the options are similar. Yes or no?
Yes, sir.
So you'll have to check two
So,
more options.
your
And I think when you check two more options, the answer that is given to me is C. That is the answer that is given here. We can check it. Shall I move or
done, sir.
everyone understands this?
Yes, sir.
Okay. Now, if this question would have come, you could, instead of writing the values here, you could have written this in this way. Probably see. A is fed here, yes or no?
Yes, sir.
And let us say here it is X. So your Y becomes AX bar, yes or no?
Yes, sir.
Yes or no? Yes or no?
Yes, sir.
I'm trying to solve the same thing by Boolean algebra. It is A into X bar. Now what is X equal to?
A plus B.
So it is A into A plus B ka entire bar. Yes or no?
Yes, sir.
We need to take deep breaths and see what is going to come.
A into X.
So A into A is A
A. Yes, sir.
and A into B is B and it is bar of this. Yes or no?
Yes, sir.
So I can take A outside 1 plus B and the entire thing ka bar. Yes or no?
Yes, sir.
1 plus B is 1.
1.
A into 1 is A.
So
So
it
the
is
answer is simply
A bar.
A bar. So I could have solved this by this way.
Yes, sir.
And the only option which matches here, now you can see, is option C. Y has to be the inverse of A, nothing else. Do we get this?
Yes, sir.
So it's a NOT gate effectively for A. For A, it is a NOT gate. So you could have done this question in this way also, my dear friends. Do we understand this or this has gone above our head? Saying bye-bye.
Answer.
Thank God. Let me now present to you this question. This question is from JEE of 2022. The logic gate shown above is equivalent to what? So how are we supposed to do this? There are 1500 different ways. I will use one of those. This is A and this is B bar. Yes or no? This is an OR gate. So your final result C is A plus B bar, the entire bar. Yes or no?
Yes, sir.
Then we need to take deep breaths and try to remember something known as the what? Obviously, we don't remember it. The The Morgan's theorem. A plus B bar is A bar dot B bar. If you remember this, then this question comes in a flash, faster than a flash. So now, my dear friends, I can write this using Morgan's theorem. I can write it as
R
A dot
dot B double bar.
B double dot.
Yes, sir.
Yes, sir. Then it is A
A bar
dot
dot B.
A bar dot B, and the only option which matches is option 4. And the answer is option 4, not 3. You will have to be patient and remember simple things. The mistake that you are making is not worth what your age is. If I can tell my 8-year-old kid this thing, he will be able to give me the correct answer for this. Trust me. He knows addition. He also knows multiplication. He will be able to give me an answer. So if you are doing a mistake, that means you are not being careful. Savdani hati, durgatna ghati. As soon as the precautions go away, accidents happen. And in your case, the accident is going to be quite devastating. But as I always tell you, you always have a chance to redeem yourself. This is your redemption. Chance to redeem. Let's see who gets redemption. Let me help you out. Yes.
Second option.
Second option is the correct option. You see, you can always redeem yourself. Redemption is there. Now, you can see that we have applied A here and A dot here, A bar here, B here and B bar here. Yes or no?
Yes, sir.
And then we have applied a NOR gate here. Yes or no?
Yes, sir.
So your final answer Y will be equal to AB bar plus BA bar, the entire bar. Yes or no?
Yes, sir.
Even if you just don't solve after this, you can just put the value of A as 0 and B as 0 here and see what is your answer. Then you can put the value of A as 1 and B as 1 and get the answer. You will get the answer as B. You don't need to solve after this also.
Yes, sir.
Do we understand this?
We understand.
Once you understand the Boolean algebra, everything should come on its own. It's very simple and straight forward. This is again a question from 2022 JEE. Draw the output signal Y in the given combination of gates. Sorry, there are 4 options also given here. I must have given you those 4 options. I forgot. Here are the 4 revolutionary options. You have to tell me which option is correct. So how are we supposed to do this? As you can see, here it is A, here it will be A bar, this will be B. So this will be A bar plus B, which is the OR gate, then it is the NOT of this. Yes or no? Do you understand what I have written here? So using the De Morgan theorem, I can write it as A dot B. Yes or no?
B bar. Yes, sir.
A dot B bar. So if I can write the truth table, A, B, and Y. If A is 0, 0, 0, 1, 1, 0, 1, 1, what will be Y? In first case, it will be 0. In second case, it will be 0. Yes or no?
Yes, sir.
In third case, it would be 1. In fourth case, it would be 0. So you will only get 1 in the output when both are on. You'll only get 1 in the output when A is on and B is off. Yes or no?
Yes, sir.
Which option matches it? A is on, B is off. A is on, B is off. Option number 4. Here it is off, and from here it is on. Yes or no?
Yes.
Here it is off and off. Off and off will not give you anything. On and off. Here it is on and here it is off. Only the combination of on and off will give you 1. The correct answer is option 4. Do we understand how this is done? Yes or no? No or yes?
Yes, sir.
Everyone understands this?
Yes, sir.
No one has any doubt? Do we understand this? How it is done?
Yes, sir.
Okay. Then let us come to the other type of question, JEE of 2022. In the logic circuit shown in the figure, if input A and B are 0 and 1, simple. A is 0, B is 1, what is the output? And the answer is 0. Everyone understands this?
Yes, sir.
Let us move ahead and do the next question. Again, this is from JEE of 2022. The following logic gates is equivalent to what? I'll give you a minute to give me the answer. NOR is correct. Remember, this is 2 NOT. 2 NOT plus NAND
And is or
gives you OR, and the inverse of OR is NOR. So the answer is NOR. Everyone understands this?
yes, sir.
So, bacha, as you can see, the questions are pretty damn simple. One more question from the JEE of 2022. I told you, if one question comes from one section in one session, same question will come from different sections, from the same section in different sessions. This is the next one from the JEE of 2022. What is the answer?
Two, sir. And gate.
And the answer is an AND gate. I told you 2 NOT plus NOR
Or
will give you AND here,
and yes, sir.
and the inverse of AND is
And
NAND. So the correct answer is this one. Are we able to understand what we are doing here?
yes, sir.
This is going above our head saying bye bye.
We understand, sir.
This is a question from JEE of 2019. And let me have the answer. What is the output of the given circuit? So I have A here, I have A here, I have B here. This is an AND gate. So what will this produce? This will produce A dot B ka inverse, yes or no? Then this is again a NAND gate, so it will produce A dot A dot B ka inverse. This will be B. This gate will produce A dot B ka inverse plus B, and the final gate will produce a NAND of this. So it looks like a very complicated scenario over here. Yes or no?
Yes, sir.
You will have to solve it using Boolean algebra. So if you just solve simple things first, if you can solve this part, what will be the value of this part?
A bar dot A. Like, sorry. A bar.
So first you can solve A dot B ka. What is A dot B ka bar?
A bar plus B bar.
A bar plus B bar. Then you can solve A dot A bar plus B bar. What will be A dot A bar plus B bar? This will be A dot A bar plus A dot B bar, and then you will have the bar of this. Yes or no?
Yes, sir.
What will be A dot A bar?
0.
A dot A bar is going to be 0. So basically you will have A dot B ka bar. Yes or no?
Okay. Yes, sir.
Now you can again use Boolean algebra. A dot B ka bar was again
A bar
A bar
plus B.
plus B double bar.
That is A bar plus B.
So this is A bar plus B here. Yes or no?
Yes, sir.
So on that side we have A bar plus B. On this side again we solve A dot B is
Plus B.
A bar plus B bar plus B. Yes or no?
Yes, sir.
What will be B bar plus B?
0.
B bar plus B will be 0. Yes or no? B bar plus B will be 0.
1, sir.
1. And A bar plus 1.
1.
A bar plus 1 would be equal to 1. Yes or no?
Yes, sir.
So now I get a NAND gate from here. So it will be A bar plus B dot 1 ka bar. Yes or no?
Yes, sir.
So again I have to apply that theorem, De Morgan's theorem. So this will be A bar plus B ka bar plus 1 bar. 1 bar is 0. So we forget about this. Yes or no?
Yes, sir.
Then we again apply the De Morgan's theorem and I will end up with
A dot B bar.
A dot B bar, and that is the answer for this one. If you have to do it by the truth table, it will just look too complicated and you may not be able to make out. So De Morgan's theorem, that is the reason De Morgan's theorem was told to you. Do you understand this?
Yes, sir.
This is the most difficult question that I have seen. You may not get this question, but even if you get the most difficult ones, this is the way you have to solve them. If you remember the De Morgan's theorem and the basic Boolean algebra, you should be able to solve the most difficult questions. Only in the most difficult ones we will be required to use them. Do we understand this?
Yes, sir.
Well, that brings us to an end of this class. That brings us to an end of logic case. Only one thing now remains in your modern physics, and that is your communication system. You are supposed to get maybe one question in some session. So we'll try to cover it in the next class. Remember, we just have to note down the important points. The theory is just too complicated. I will try to make you understand in the simplest way, and you just have to remember the important points. And from those important points, you are going to get question in your exam. So I'll see you tomorrow with the communication system, and with that, we will bring an end to this chapter. Semiconductors will bring an end to the chapter on modern physics. Take care, and I'll see you tomorrow. Bye bye.
Thank you, sir.